this later on Canvas, so you could kind of take a look at it. So 68.8% carbon. I'm going to convert that to grams. And you will see, like I put on my video, that I always like to write things one underneath each other so I could kind of work across in the problem so that it's easier for me to kind of keep track of numbers. So first step is to convert everything to grams, Then what I'm going to do is divide by their respective molar masses. So divide by carbon, hydrogen, and oxygen's molar mass. So carbon is, of course, 12. Hydrogen is a mass of 1 gram. And oxygen is 16 grams. And again, you could set this up as proportions if you'd like to do proportions instead. But I typically show it this way. So 68.8 divided by 12 is about 5.73. And that is the number of moles of carbon. And then, of course, this is 4.95 moles of hydrogen. And then 26.25 divided by 16 is about 1.64 moles of oxygen. In reality, this is actually the formula already. Okay, so I could write C 7.53, hydrogen is 4.95, oxygen is 1.64. But we like to do things in whole numbers. So really this last step is to get something to 1. So what we do is we look at the 3 numbers and we say, okay, which one is the smallest number? The smallest number in this combination is 1.64. So 1.64 is what I'm going to divide each one of these by. So that gets the oxygen to 1. Well, the reason I picked this one is because these numbers don't come out pretty, okay? Nice numbers, whole numbers are great, but this comes out to be about 3.49, which is approximately 3.5. And this comes out to be about 3. So that one is okay just on its own. It's like 3.01. And again, we're not going to be crazy about our numbers, but we are going to make the following statement, okay? So this is 3.5 essentially. 3.5 cannot be rounded down to 3, and it cannot be rounded up to 4, okay? 3.5 is 3.5. So in terms of chemistry, what we have to do is multiply this by a number to get it to a whole number. Okay, and I'm going to give you pretty easy numbers to look at so you don't need to worry too much about some freaky things. All right, so I have to multiply that by 2. But the mistake sometimes made by students is they forget to multiply by 2 by everything. So whatever I do to this, I have to do to everything else in the formula. So that's going to give me a 7. That's going to give me a 5. That would be adding 3 plus 2. Oops, that's a 6, and that's a 2. So my final answer is C7H6O2. That is my empirical formula for this compound. So any questions on that so far? So if this is your empirical formula, one additional thing I'm going to ask is about the molecular formula. A molecular formula is going to be some factor above the empirical formula. So it's always going to be a multiple of the empirical formula. But for the molecular formula, I have to give you information. You can't just be like, oh, this is the molecular formula. And molecular formulas is how it exists in nature. Okay, and I talk about it in the video. I talk about the fact that I think I mentioned glucose has a molecular formula. Its empirical formula is somewhat lower than that. So if the molecular formula for this new compound is 366 grams per mole for the molecular formula, using this as our empirical formula, what you have to do is essentially add up the empirical formula's molar mass to figure out how many factors above it do you get to 366. So the empirical formula here is C7H6O2. So what I have to do is take 7 times 12, which is the mass of carbon, plus I need to take 6 times 1 gram of hydrogen. And then I got to take 2 times 16, which is the molar mass of oxygen. So I have to add these all up to get the molar mass of my empirical formula, which happens to be about 122 grams per mole. So that's my empirical formula molar mass. So all you got to do is take the 366 and divide it by the 122, and you will find that that's a factor of 3. And when you do this, it should come out to be pretty much the right number in terms of a whole number. So the molecular formula is 3 times that, the empirical formula. So what you do is you take the subscripts and you multiply it by that factor. So it's C21H18O6. So that is the formula of the molecular coming from the empirical formula.
How'd you get that 3-to-1 thing again?
So the 366 is the molecular formula molar mass. So I divide that by the empirical formula's molar mass. So I try to figure out how many of these essentially do I have in this bigger number. So this has to be, the 366 has to be given to you in the problem. That's not something you're going to just know.
Oh,
so
okay.
So I have to give you the molecular formula's molar mass. You could add up the empirical formula's molar mass and divide that into it. Okay, any other questions? Okay, so I'm gonna give you an option. If you want to stay on, I could do another practice problem with empirical formulas with you, and you could try it out with me. Or you can say, hey, I'm good, Miss Brucker. I don't need any more additional help. This looks good. I'll try it on my own and see how it goes. Okay, so again, have a wonderful weekend. Stay on the Zoom call if you want to talk or do an extra practice problem. Nice job. Have a good Friday.
Thank you.
Bye. Have a good weekend.
Thank you. Thank you.
Bye.
Have a good weekend.
You too. So Yasmin. Benjamin, did you want to see another practice or did you have a question for me?
I was hoping we could do another practice problem.
Okay, sure. Nico, you want to stay on and watch me do a practice problem?
Yes.
Okay. Yasmin, are you still there or are you gone? Okay. All right, so I'm going to do another problem. Okay, so let's do, okay, let's do this one. So I have a compound that contains carbon. I have 75.46%. Hydrogen, I have 4.43%. And I have 20.11% is oxygen. So see if you can find the empirical formula. Okay, so you're going to take the 75.46, the 4.43, and the 20.11, and you are going to convert it to moles. So just like in this first step I did. And then you're going to divide by the smallest and see what numbers you come up with. So I'm going to give you a minute here for you to try it on your own, and then I'm going to show it to you. Okay, so 75.46, 4.43, and 20.11.